Hey everyone, today we're going to talk about inequalities. We talked about equations last time, so we're going to look at the inequalities and we're going to see how we do those. This is a continuation of the documentation I gave to you. Let's take a look. So here are the documents. Here's a document, I should say. And last time we talked about the equations above. Okay, we hit the inequalities and we stop. So basically, the inequalities are the same as equations, except when you multiply or divide by a negative number, you must change the direction of the sign. Otherwise, it's the same exact process. So I have several examples here. And so let's take a look at these examples. This is on a PDF I will be sending to you. So let's take a look. So this has the equations on. Now the first thing I want to do is I want to talk a little bit about number line versus interval notation solution. Okay, you might be familiar with the number line solution. So here's the thing. If you keep x on the left side, whatever direction this inequality symbol points, that's the direction you arrow. If you have a greater than or a less than, you keep the circle open on the number line. If you have a greater than or equal to or a less than or equal to, you shade in the circle, you close it. Open means it's not included, shade means it is included. Okay? If you keep the x on the left again, whichever direction this inequality points, that's the direction you arrow. So for example, we have x is greater than 3. So that means we draw open circle at 3 because it's a greater than. That's what we call a critical point, 3. And we arrow to the right because this arrow points to the right. Now what this means is that you can put any x value in except for 3 that's to the right of 3. So you can put in 4 or 4.1 or 5.8 or 5 or 12 or a million. All those will make this inequality true. The difference between an inequality and an equation is an inequality has many solutions. An equation typically has one. Okay? If the x ends up on the right, then you arrow in the opposite direction. So if I take a look at this one, x is less than or equal to minus 5. So since x is less than or equal to minus 5 and x is on the left side, this arrow points to the left. So that means I'm going to arrow to the left. So I make a closed circle at minus 5 because it's less than or equal to, and then I arrow to the left. For compound inequalities mean we have 2 or more inequalities in the problem. So in this case, we have something like x, or 3 rather, is less than x is less than 7. So that means x can be anything between 3 and 7, but it cannot be 3 or it cannot be 7 because they're strict less thans. So when we shade this in, we have a critical point at 3 and at 7. We keep this open. And since x is between these two, we shade everything between. If one or both have equal in them, then we shade that particular critical point value in. So in this case, we have 3 is less than or equal to x. So that means at 3, we shade that in. And x is less than 7. So that means we keep that open. So still x is between 3 and 7. So we shade everything in between 3 and 7, but we close off 3. Now that's very similar to interval notation. Interval notation uses parentheses and brackets. It almost looks like an ordered pair, so watch out here. Okay? You got to look at the situation. Parentheses mean open at the point. So that's like a less than or a greater than. Okay? Brackets mean closed at whatever point we have here. So that means like a less than or equal to or a greater than or equal to. We could have half open or half closed. Okay? So one of them is a bracket, the other one's a parenthesis, or parenthesis to bracket. Okay? So let's go back up here and take a look. So this would be a parenthesis at 3. And it go forever in this direction. Now, forever land in this direction is positive infinity. So we put a parenthesis at 3 and then to positive infinity. For this one, we have a bracket at minus 5. Why? Because it includes minus 5. And it goes to forever land this way, which is negative infinity. So at the infinities, we always have the open. So we'd have a parenthesis at negative infinity all the way up to minus 5. And at minus 5, we'd have a bracket. For this, we'd have a parenthesis, whoops, went too far, hang on. For this one, where 3 is less than x is less than 7, we'd have a parenthesis at both 3 and 7 because it doesn't include that. So it looks like the ordered pair 3, 7, but it's not. It's 3 comma 7. And in the context that it's in, it's the interval between 3 and 7. For this one, we have a bracket at 3 and a parenthesis at 7. And so basically I look at that and I just do what I just said. So when you see this lazy 8 symbol, that's infinity. When you see the lazy 8 symbol with a minus in front of it, that's negative infinity. Okay? And so that basically is just what we talked about. So let's take a look at some examples. Okay? And we'll do the interval notation for them. So 11p minus 36 is less than 7p minus 28. So we'll group the p's on one side. We'll group everything without a p on the other side. So that gives us 4p is less than 8. We're going to divide now. This is where we have to watch out. Okay, since we're dividing by 4, nothing changes. So we keep the direction the same on the inequality, and p is less than 2. So that means it goes forever to the left. So that starts at negative infinity with a parenthesis around it, all the way up to 2 with a parenthesis. For b, we have minus 4x minus 6 is less than or equal to 18. And we have the x's grouped already on this side. So we'll add 6 to both sides. We get minus 4 is less than or equal to 24. Now here again is where we're going to divide. Since we're going to divide, and we're going to divide by a negative number, we have to change the direction of the inequality. So we divided by negative and got the negative 6 because 24 divided by negative 4 is negative 6. That said, since we divided by negative, this is no longer going to be a less than or equal to. It changes to greater than or equal to. And so this means that x goes forever to the right, starting at minus 6. So it includes minus 6 because it's a greater than or equal to. So we put a bracket around that to positive infinity. Infinities always have the parentheses. And then similarly, we're going to do basically the same thing here, except we have to distribute the 2 and combine some like terms. So we'll distribute the 2, and that gives us 2y plus 12. Adding the 9y and the 2y together, that gives us 11y plus 12. And there's nothing really to do at this moment on the other side. So that 11y plus 12 is greater than 5y minus 24. So we'll subtract 5y from both sides, and we'll add 12 to both sides. So that gives us 6y is greater than minus 36. We'll divide both sides by 6. Since 6 is positive, there's no change in direction. And so that gives us y is greater than minus 6. So that means we start at minus 6, not including it, so there's a parenthesis, and we go forever to the right. So that means we go to positive infinity. For some compound inequalities, so think about this. If you covered up this 9, let's suppose that 9 wasn't there, okay? And we just had 5 is less than 4x plus 1. You would subtract 1 from both sides. Now, if we covered up the 5, let's pretend, whoops, I'm not going to cooperate with me this time. Let's suppose that 5's not there. Okay? We'd still subtract 1 from both sides. So what we can do is we can do that all at once. So we'll subtract 1 from the 5 and from the 9. That gives us 4, and also from the 4x plus 1, I should say. So that gives us 4 is less than 4x is less than 8. So that means then we can now divide by 4. Same way we subtracted the 1, we're going to end up dividing everything by 4. 4 over 4 is 1, that's less than x. And 8 over 4 is 2, so x is less than 2. And so again, open at 1, open at 2. Or open circles at 1 and 2 with everything shaded in between. And now keep in mind, since 4 is positive, we didn't change the direction of the sign. If we did divide by negative, then we'd have to change the direction of the sign. So let's take a look at this. So again, same idea. If this 8 wasn't here, I'd subtract 2. If this minus 8 wasn't here, I'd subtract 2 from this. So I'm going to subtract 2 all the way across. So that gives us 8 minus 2, or minus 10, is less than or equal to 5x, which is less than 8 minus 2, or 6. And just like before, we'll divide by 5, and we'll divide everything by 5, just like we did the minus 2. We subtracted 2, so we're going to from everything, and we'll divide everything by 5. So 10 minus 10 over 5 is minus 2, and 6 over 5 is 6 over 5. And so we're closed at minus 2, open at 6 over 5. Again, there's our number line solution. In this last one, same idea. We'll add 2 to everything. That gives us 4 is less than or equal to x is less than or equal to 0. Divide by 2. That gives us minus 1 is less than or equal to x is less than or equal to. Now, when I take 0 divided by 2, a lot of people get confused with this one. 0 divided by 2 is 0. 2 divided by 0 is undefined, so you cannot divide by 0. But when you divide into 0, it's 0. Okay. And that's it for today. Hopefully this helps you out a little bit. Have a good day.